Good morning, everyone. I am Dr. Aruna, Assistant Professor from the College of Business, Liva University, Abu Dhabi, UAE. I am co-authoring with Dr. Nidhi Oswal and Dr. Karamat. It is our pleasure to present our research in this esteemed conference ICOA 2025. Our research, titled Global Indicator-Based Macroeconomic Forecasting Using Bayesian-Gaussian Processes, it deals with the GDP and inflations, which are independent signals and traditional model conversions, as well as comparisons with the new digital side. Modern as well as traditional comparison has been completed in our study. The agenda goes like this: abstract introduction, research gap, methodology, about the framework and the evaluation and limitations of our study. The study combines Bayesian-Gaussian processes, which is named as BGP, with world economic indicators. The proposed system have, in comparison to traditional linear models, developed to effectively capture non-linear relationship between the indicators as well as macroeconomic trends. Gaussian process framework, it facilitates a non-parametric learning always, and the use of Bayesian methods in models it always increases reliability as well as accuracy. Our system is designed to adapt the shifts as well as turns of the world economic automatically. It represents a significant gap or a significant step in economic forecasting. The main motivation behind our research. What or why this research matters? The macroeconomic forecasts are critical for businesses, governments, and policymakers. So the need for adaptive, accurate models is growing due to volatility in global economies. The main purpose of this paper is to offer a solid, adaptable system that enhances macro forecasting. The purpose is to enrich the quality of economic forecasting processes based on non-parametric probabilistic model, which is completely independent. It involves the most reputable and a contribution of the research work also. Here GDP as well as inflations are like interdependent signals. Traditional models see them as linear, but reality is much more tangled. The problem statement is mainly the traditional part. The traditional models, they struggle with high volatility, non-linearity, and structural shifts also. The lack of uncertain quantifications and adaptability are also the problems considered in the traditional model. We recognize the research gap from the existing literature reviews. Existing models, they do not capture global interdependencies well, as well as insufficient treatment of uncertainty exists always. There is a limited adaptability to real-time changes. Macroeconomic forecastings. The key indicators in our work are GDP, inflation, unemployment rate, and trade balance. Traditional models are vector autoregression, ARIMA, linear regressions, and so on. The limitations in the traditional models are always they assume linearity, and limited adaptability are the major limitations. Therefore, we need to switch or shift it to machine learning. Machine learning models, they handle complex, non-linear patterns even. The growing interest in AI-driven economic forecasting resulted in our research. The Bayesian approaches. The advantage of Bayesian approaches are they always incorporate prior knowledge, probabilistic predictions, and better handling of uncertainty conditions. Gaussian processes always they are non-parametric models and they define distributions over functions. They are more flexible and interpretable. They have strong uncertainty quantifications also. The related works are studies shows Bayesian machine learning models which improve the forecasting, Bayesian VAR is applied dynamic factor models are there. Bayesian Gaussian processes in monetary policy also available. Our framework has a wide overview. The BGP based forecasting framework is given like this. Inputs are usually considered as global indicators, and pre-processing and normalization is the second part after the input. Gaussian process regression has been carried in the third step, and Bayesian inference and the fourth step, finally recursive forecasting, has been completed. So this is our framework, which shows clearly about how the inputs are given. We can see clearly the system process global indicators are given as input, and after the input, pre-processing and normalization takes place, and we train the models on multidimensional data. Then model learns relationship between the indicators as well as the outcomes, and it incorporates prior knowledge as well as the quantifying the uncertainty. Then it updates the predictions with the new data. Finally, it generates confidence intervals around the forecast. So this framework easily provides us the machine learning output. Our input variables are indicators which are GDP, inflation, unemployment, and trade balance. Pre-processing and normalization are the second processing in our framework. Here standardization ensures comparability as well as scales raw data to consistent format. Then the mathematical foundations are applied. Here we apply GP prior as well as kernel function. So f of x is function kernel, which is also called as a kernel function. It acts like a similarity detector. It is helping the model find hidden patterns in economic data. And the posterior distribution also we applied P of f of x with respect to x and y, and we made parametric optimization. This hyperparametric optimization is done via maximum marginal likelihood. We apply L theta function. Then recursive forecasting has been updated by f of x in terms of t plus 1 also, which enables multi-step prediction and adaptability. The evaluation steps are the main thing. We have set up thresholds for the indicators. So GDP growth, we set up 4% threshold, inflation 2.5% threshold, and unemployment 6%, and lastly trade balance $2 billion. The GDP growth analysis shows the value range lies between 2% to 5%, and it peaks actually at 4.8%. The threshold breaches indicate economic booms in the variations. Inflation variation values ranges between 1 to 3%, and it peaks at 2.9% from the analysis. Threshold breaches indicate inflationary pressures. The picture clearly depicts how the threshold value has been breached. You can see the threshold value taken as 2.5% in this red line, which is a dotted line. We can see the maximum inflation rates which is going beyond the threshold range, which are not acceptable range. That's why it's shown by the red square boxes, which is above the threshold limits. So here we see that inflation crossing 2.9. So this is a warning point for policymakers to act early. The range of unemployment is 3 to 10%, and it breaches at 3, 6, 14 times steps. Peaks at 9.5% signals labor market stress. This is the picture which shows the unemployment rate analysis, where we can see the threshold at 6. So this 6% is threshold, and our analysis is showing more than 6%. The trade balance analysis range between 2 billion to 5 billion $, and its threshold is also given as 2 billion $, and it surpluses at step 7, 12, and 18. We can compare the traditional as well as the machine learning process, and a proposed BGP as well as traditional comparison provides better accuracy, and it captures non-linearities also, real-time adaptability also, and it provides uncertainty bounds also. In the picture we can see the trade billion versus time. Here the threshold has been set to 2 billion US dollars, and our trade balance is above the threshold values which are exceeding, and it is also a warning point for the policymakers. So uncertainty quantification, always predictive variance, which is reflecting the reliability. It supports risk-aware policy making. So we consider it as a warning point for policymakers to act early. Key contributions regarding our proposal: it is a novel BGP based forecasting model which captures non-linear global economic relationship, and it provides uncertainty quantifications and adaptable to new data. The policy implications informs government policy, and it supports risk management also. It enhances business decision making. The limitations which we are suggesting from our work are: it requires high quality input data, and computationally it is intensive, and it is more sensitive to kernel choice. In summary, our work demonstrates how Bayesian Gaussian processes, when combined with the global economic indicators, can provide a more adaptive, accurate, and reliable forecasting system than the traditional methods. By capturing non-linear relationship and explicitly modeling uncertainty, our approach bridges the gap between classical economic theory and modern machine learning. We propose future work from our findings. They can explore hybrid models, they can extend the data set coverage, integrate real-time policy applications also. We believe this model has strong implications for policy making, risk management, and the strategic business decisions, particularly in today's volatile global economy. Thank you for your attention. Thank you once again.